Hello, I'm Aaron Catto. In 2006, I released Box2D, an open source 2D physics engine for games. In 2022, I began work on Box3D, bringing the technology behind Box2D into 3D. Like Box2D, Box3D is an open source project, and it always will be. In this video, I want to introduce you to some of the features of Box3D and the samples app. And then if you stick around to the end, you can see the recording and replay feature being used in the game project I'm working on now called The Legend of California. The Box3D repo provides a samples app. This contains many tests and demos, as well as a replay viewer. Here is the Box3D samples app. When you first run it, you'll get this window that shows the controls. There's a lot of controls, so if you ever need to refer back to them, just go to the Help menu. When you first run the samples app, you may want to look at the frame rate. If that's low, you may want to adjust the render options. In particular, GTAO, which is the ambient occlusion, can be kind of expensive, so just turn that off. A lot of the samples have solver controls for adjusting the simulation parameters. So substeps is kind of like the number of iterations, but it's the solver uses substepping. Instead, there's also the simulation hertz you can adjust, and you can adjust the worker count for multi-threading. All right, let's look at some samples. There are over 150 samples. I'm going to show a few of them that demonstrate some of the interesting features of Box3D. But first, let's get started with the single box sample. Box3D sample app has supports for selection, so I can select the ground box, and then if I press F, it will zoom out to encompass that ground box. I can click any rigid body and then zoom in on that. I can use the Alt and left mouse to orbit, mouse wheel to zoom in and out, and the usual kind of orbit camera controls. You can also right click and then do WASD first person controls. If you want to manipulate a rigid body, you can hold Control and then left click, and then you get the mouse joint. You can view contact points as well. We're not seeing them right now because the body is asleep. So I'm going to disable sleep, and now we see the contact points. And let's also look at the contact forces. So the contact force representation needs some scaling. The forces are creating very long lines. So I'll go in and change the force scale. Let's put that to your 0, 1. Yep, that looks good. And I may want to view this with transparency to see some of the details. And then I can see how the contact points and forces change as I drag the box around. There's some other things you may want to see. For example, the body mass, and this also shows the local frame. You can view the bounding box. That's what's used in the broad face. So that's it for the single box. Let's look at something else. Okay, let's talk about how to navigate to different samples. There's a few ways to do it. You have the samples menu. You can hit Control O and search. And you can also use the square brackets to go forward and backwards between the samples. So let's open another sample. I'm going to open the large pyramid. This sample is interesting because it shows performance. So to look at performance, I'll open the metrics tab. All right, the pyramid fell asleep, so of course it's very fast. So let's disable sleep. And we can see the performance timings. This actually scrolls down and you can dig into the details. You can look at counters that show kind of the quantity of stuff that you're dealing with. There's some information about the renderer, and then there's also frame times. The Box3D Samples app is also kind of designed to be fun for me, so you can throw objects and see how things behave. So I can throw ragdolls. All right, this has been fun. Let's look at another sample. This sample shows how Box3D handles gyroscopic torques. But first, you can see that nothing's moving. That's because it's paused. So in the sample app, you can press P to pause and unpause, and you can press O to single step when paused. So here I'll unpause it, and you can see this pretty amazing looking motion, but this is actually physically correct. There's no gravity on this object, but this effect has been observed on spaceships, and you need to simulate gyroscopic torques for that. So this is a great test of that system. But gyroscopic torques are useful for regular movement of rigid bodies so that they don't spin in strange ways, and they're actually obeying conservation of angular momentum. This is a falling tree benchmark. It really stresses mesh collision, bodies with multiple shapes, and continuous collision. Currently, the mesh cell width is 100 centimeters. Let's change that to 50 centimeters. And this becomes even more challenging. Box3D has support for character movement. So this blue capsule is a character mover. It's actually not a rigid body. It's just a sequence of geometric queries. So the main queries are shape casts, and then there's another query that gathers collision planes, and then there's also a collision plane solver. So this is good for network games where you want more kind of gamey character movement and not really wanting a rigid body character. One of the features is soft collision. So the red capsule there might be an enemy, so you want rigid collision, but then the green could be an ally, so you just kind of squeeze out of them slowly. This character mover, just in the sample code, I've implemented this kind of pogo thing. That's not really part of the library, but you're welcome to look at the pogo code and make use of that. And the pogo is very good at kind of just smoothing out movement. A lot of games use ramps, and if you have a pogo, maybe you don't need to use a ramp. Yeah, you can see it kind of smooths out movement over these bumps, which are very common in games to have bumps like that. So it's handy. I also in the sample code have some example of how to make the character mover interact with rigid bodies. So this is like a door, and it's has a pretty good kind of interaction there. Yep, and then Over here, this is height field, just another kind of test. And the height field in Box3D supports holes. So that's what those empty spots are. All right, so that's it for the character mover. Another feature I've added to Box3D is support for pre-computed compound collision or baked compound collision. And the idea is you may have a streaming game that has a lot of static collision, but maybe that static collision is assembled from a bunch of different separate collision shapes, like a bunch of holes or a bunch of meshes. And that is common in a level design practice called kit bashing. Now, if you just bring each mesh and each hole into Box3D, you're kind of creating a lot of bodies and a lot of shapes, and you have to insert each of those elements into the broad phase one by one, and that's a slow process. So this pre-computed or baked compound collision allows you to offline take as many shapes as you want and kind of put them together into one big static shape, Uber shape. So this scene here, if you look at the numbers, it has 5,000 capsules, 40,000 holes, and 2,500 meshes. And you look at all this and imagine just streaming all this in bit by bit would take quite a long time. If you look at the counters for this world, there's actually only one body and one shape. So this blob that you would load in, it would come in as one shape, and it would load, at least into Box3D instantly. Now, of course, you're going to have some asset there that you're going to have to load off a disk, and that would be, part of your streaming system. But it behaves just like regular collision at the end. So it performs very similarly to what you would get if you inserted things one by one, and maybe even better. One of the nice properties of this system is that each one of these meshes you see here, this building, is just an instance with support for non-uniform scale, mirroring, all the things that you would want in kind of a kit bashing setup. And so there's actually these are all basically instances, and it's done in as light a way as possible. So it's just like a transform and minimal data for each instance. Box3D has kind of basic support for vehicles. It has a wheel joint, and for spheres versus mesh, I have mitigation for ghost collisions. So you can have vehicles with sphere wheels and it will move pretty smoothly. I also have a special constraint that can help you with tip over. Let me see if I can make this guy tip over. Easiest way to do that is with the mouse joint. So you can see it kind of wants to come back. So that's a nice feature to have if you don't want your cars to tip over. This sample shows some of the benefits of the substepping solver, which is basically the same solver that's in Box2D, and it helps you deal with larger mass ratios than you can achieve with a regular iterative solver. So here these gears are working just purely based on collision of the gear teeth. Another feature I brought from Box2D is rolling resistance. So this allows you to have spheres and capsules that can completely stop rolling even on an incline. This is great if you want to have spheres or capsules and you don't want them to roll forever. It also can help stabilize movement of things like ragdolls. Even if they're not really rolling, the added kind of rotational friction can help with stability. And Box3D even supports the rolling resistance on convex hulls. So when you saw that tree sample, those trees are actually experiencing rolling resistance. And you kind of need to dial that in so you don't get something weird where uh, something is standing on end, but that is usually fairly straightforward to tune and get a good value there. I've brought over another feature from Box2D called contact recycling. Contact recycling provides a massive performance gain, and it also makes stacking more stable. With contact recycling, you can get very stable vertical stacks of boxes, yet it still behaves realistically. Now, this requires some tuning. I found the sweet spot is 5 centimeter tolerance on that. If you set it down to 0, that essentially turns off contact recycling and you lose that stability gain and you lose the performance gain. On the other hand, if you push it too far, here's at 10 centimeters, it can become unnaturally stable. There is also an option to turn it off per body. Recording and replay is a feature that helps you debug your game's physics and collision. You will start a recording in your game and then continue that recording for some number of frames. And when you're done, you stop the recording and you save that file to disk. Then you can load that file into the Box3D replay viewer and you can visualize and debug your game. I'm going to give you an example now of how that works in The Legend of California. Here I am in The Legend of California. There's a nice sunset, and I'm going to do some tree chopping. So I'm going to start recording the server for 5,000 frames. All right, I have a tree here. I hear something coming. It's a dangerous place here. Anyway, tree's chopped. Maybe I should heal myself. All right, chop some logs. All right, hopefully I got that all recorded. I'll see you in Box3D. All right, I'm back in Box3D. I'm going to load the recording. And here I'm going to give a pretty big memory budget, giving 4 gigs. But I'm going to spread out the samples for the keyframes. So space of 64 should work fine. You might want more narrow spacing if you have a lot of simulation. But this is not that many rigid bodies that are moving. It's just mainly a lot of static stuff. Okay, so this view looks kind of bad. What's going on here is Unreal has Z up and the convention in this app is Y up. So I have a toggle here that brings it into a Z up view. And then I'm also going to want to see all the queries that are happening. So if I start to move forward in time, you can see a bunch of queries. And this is going to help me find my character. So I'll pick an object over there, focus on it. Right. So there's my character. Can kind of go back to the beginning. It's kind of interesting. You can see over there in the background is that coyote, and that coyote is doing a long raycast to me to see if he can see me. And he's seen me. Yep. You can also see the capsule for his character mover and his raycast to position that mover on the ground. So, yep, he's coming at me right as the tree starts falling down. But let's focus on the coyote for now. So he's coming at me, still checking line of sight. I think he jumped and attacked me. I hit him. I think he's coming back. All right. He leaped at me again. And there, I took care of him. So we can see he transitions from character mover into ragdoll. He's still doing some ground traces. I think we have that for knowing if the character's on the ground or not. That's still kind of relevant in some cases, but maybe not in this case. So maybe that's something we can optimize. And there we see, okay, the coyote ragdoll's gone to sleep. We can view some stuff that might be interesting, like let's view the contact points and the normals. So we can see, yep, there's a lot of contact points. The coyote, we can focus in on the coyote, see what's going on there. It all looks reasonable. All right, and as a physics programmer, there's a few things here I'm interested in, and it's mainly related to performance. So one, I want to know when that tree falls down, is it going to sleep pretty quickly? Yeah, and it does. So when it's that darker grayish color, it's gone to sleep. So that's great. And then also that ragdoll goes to sleep pretty quickly too. So that's great for performance. Another thing I'm interested to see here is like, we actually have gaps between these tree segments. So that could be a problem we want to address because with those gaps, it may look like you have cover, but you could actually get shot through those. So that's something we might want to fix. Yep, and I'm able to chop up the tree, goes back to sleep, chop up those logs there, and that goes to sleep pretty quickly too. So everything looks good here. And one other thing, yeah, the replay viewer this is not the entire game. This is one of our larger test maps, but it's loading a lot of stuff. And it's pretty efficient. I believe the file that was stored for this is about 40 megabytes, so not too bad. And then generating the keyframes, it's using 488 megabytes. But you could probably spread out those keyframes even more. And this is all making use of determinism. So what's interesting is I'm running this in Unreal and I'm deterministically recreating the simulation back in the Box3D app. So that determination here, determinism is validated here because I will get an error, um, some red text that will say that the simulation has diverged, but it hasn't diverged at all in this entire recording. It has been great seeing so many awesome games built with Box2D over the years. I'm looking forward to seeing what people can build with Box3D. If you are interested in Box3D, I encourage you to join the Discord server and subscribe to this channel for updates. See you soon.